Okay, we're going to try out a few more examples of this. So here we have a vector 2, 1, -1. We want to know if it's in the span of these three vectors. And so the linear combination question that this asks is if there are any solutions. Is there any way of writing this vector 2, 1, -1 as a linear combination of these three vectors? And the way that we answer this sort of problem in general, algebraically, is by row reducing this augmented matrix. Okay, and we're going to use Sage to help us answer this question. So here we have 3 rows and 4 columns. Our entries are 2, 1, 1, 2, 1, 0, -2, 1, 0, 1, 0, -1 rather, 2, -1. Okay, and we would like to know the reduced row echelon form of this augmented matrix. Okay, and let's write this down. So our reduced row echelon form is 1, 0, 0, 5/7, 0, 1, 0, 5/7, 0, 0, 1, -1/7. Okay, so we can see that in fact there's a unique way of expressing 2, 1, -1 as a linear combination of these three vectors. C1 is 5/7, C2 is 5/7, and C3 is -1/7. So we do have the vector 2, 1, -1 is in the span of these three vectors. Okay, and I'd like you to take a quick look at the matrix here. And I'd like you to think, is it possible to have solutions that don't exist with this starting matrix? If you see here, there is a pivot in every row here. So what this means is that it's not possible to have a row of all zeros left of the augment and a non-zero element to the right of the augment. Okay. What this means is that every vector in R3 is in the span of these three vectors. Okay. So for instance, if we have this vector 5 to square root of 3, and we want to know, is it possible to write it as a linear combination of these three vectors? Notice these are the same set of vectors. We know that when we do the row reduction, the left of the augment is going to look like 1, 0, 0, 0, 1, 0, 0, 0, 1, the identity matrix. So it has a solution. We might not know offhand what that solution looks like, but we can guarantee it is going to be in the span of those three vectors. Absolutely. If we want to know how to write it, well, we would have to ask Sage to tell us. So I'm going to just insert these guys in as our augment, 5, 2, and square root of 3. Whoops, we get a slightly messy answer. Okay, so we find the C1 value is 2/7 times square root of 3 plus 16/7. C2 is -5/7 times square root of 3 plus 2/7, and we get a value for C3. But the original question was, is it in the span? And we can say, based on the matrix to the left of the augment, absolutely it is.